Hello and welcome to Calculus. In this video, I am going to show you another time how to graph a function given the graph of a derivative function. I'll take two examples and you are to complete all the examples from the notes, derivative 3, and the homework assignment 26 that you started last week. All right? I do want to see the vertical lines. So let's begin. So I am given the graph of a derivative function and I want to graph the function. Let's start with the first set of vertical lines. The first set of vertical lines denotes where the graph of the derivative is positive or negative. Positive means above the x-axis, negative means below the x-axis. So here we go, and therefore I will draw the vertical line where the derivative is equal to 0, right? Right here and right there. So you see, in this interval, the derivative is positive. In this interval, it is below the x-axis, so it is negative. And in the last interval, the derivative is positive again. All right, so what does it mean about the function? Well, if the derivative is positive, it means that the function will be increasing right here, and then it will be decreasing right there, and then increasing right here, okay? So I could almost draw the graph of my function. It's going to be something like that, increasing, decreasing, and increasing, right? But I need more information. This is not precise enough. All right. So now for the second set of vertical lines. They will denote where f prime is increasing and decreasing. So now I'm talking about f prime itself, not the function. So right here I see that my graph, actually it's almost constant right here, right? But it's decreasing, so it's going to be decreasing until here, right? So f prime of x is decreasing. And then right here, f prime of x will be increasing. All right. What does that mean that f prime of x is decreasing? It means that the function f of x is concave down, and here the function will be concave up. Okay. These are the two sets of vertical line I do want to see. And now we can graph our function. Alright, so right here I have to be increasing concave down. Alright, I think something like this will do. I'm gonna redo it, right? And then I have to be decreasing concave down, and then I change my concavity, and then I'm increasing. Okay, alright. Now before I draw it, actually, there is a last piece of information I want to record. Right here, you see, my derivative is almost constant. That means that my function is almost like a straight line, and it is positive, right? So it's like a straight line going up. So how can I do that? Well, let's see. So I have to be increasing, but like almost like a straight line, right? So here we go, increasing right here, and then almost like a straight line, right, with a positive slope. Then I'm decreasing, concave, still concave up, right? And then right here I'm becoming concave down now, but still decreasing, right? So concave down right here, and then I'm gonna be increasing, and again I have to behave almost like a straight line, and actually very much seemingly at least parallel to, I mean, I'm gonna draw a symbol from geometry here, don't do that, but these two are somewhat parallel, okay? Okay, all right, that's about it for the first example. Let's move on to the second one. Okay, so here is my second example. So the first set of vertical line denotes where the derivative is positive or negative. So here's a 0 for the derivative, right? And I can see that right here, the derivative is positive. All right, then negative, negative, negative until this point. So right here, it is negative. then positive until here, and then negative again, okay? So right here, positive, and then negative again. Okay, all right. Let's draw the arrows right below. So my function right here is going to be increasing, then decreasing, then increasing, and decreasing again. All right, I think I know how it goes. So now let's draw the second set of vertical line for the increase and decrease of the derivative itself. Okay, so my derivative is decreasing until here, right here, right? Okay, so derivative is decreasing right here. Then it is increasing until about here, right here. So right here the derivative is increasing, and then it is decreasing all the way. So f prime of x decreasing all the way. Okay, what does it mean about the function? It means that right here the function is going to be concave down, here it's going to be concave up, and here it's going to be concave down. All right, let's draw the graph now. So you have to be increasing concave down. So here we go. I don't see anything straight right here or anything like that. So here we go. So increasing concave down. Let's try this way. If it doesn't work, I'll erase and I'll place it somewhere else. Okay. Then decreasing still concave down until the red line right here. So decreasing concave down right there, and then decreasing concave up. So then decreasing, but now concave up right here. Another horizontal tangent line, then increasing concave down right here, increasing concave down right here, and now increasing concave up like that, and then decreasing. So something like that, okay? I'm pretty sure the actual graph of the function would be quite different than this one, because this looks like a polynomial, the blue graph that I just did, while the red graph given is surely not a polynomial, okay? So I'm pretty sure it's very different, but I really get the gist of it. I know my concavity, and I know where my local max and local mean will be. And I know where my inflection points will be also. Thank you for watching.